This video will cover Unit 6 in Intermediate Algebra on imaginary and complex numbers. As you guys can see from your study guide that's in front of you, there's quite a bit of information that we put together within the course of 3.5 days or so. So we will be doing this review packet. If you need more practice, then just come see me. I'll give you more. I'd be happy to give you more so that you are successful when you take your assessment. Go ahead and open up to the first page of your 5A review packet. So we're going to start here with number 1. I want to give you a few little things here before we get started with number 1, and that is that we have these complex numbers, a plus bi, where it represents a real number, say x, plus an imaginary number, say y, I. So what we do when we look at number 1, it says 2 students are playing a game involving complex numbers. One student's score is 3 minus 5i, and the other student's score is 3 minus 6i. What is the total of the 2 scores? So total meaning add them together. So we have a 3 minus 5i, and it's being added to 3 minus 6i. When we add complex numbers, all we do is combine like terms. So I see a 3 and a 3. Those are the real numbers, so they combine to 6. Then I see a negative 5i and a negative 6i. Negative 5 take away 6 more is negative 11, and it has an I attached. In this instance, I works just like an x does. You keep it, you combine them, etc., etc. We're going to take a look down here at number 4. We're asked to simplify these radicals. So what we have to do is break them down, kind of like what we used to do back in, I don't know, Unit 2 or something like that, into a perfect square and a non-perfect square. However, with the negative, that means we actually break it down into 3 radicals. And the last one will always be a negative 1. So we have 8 radical, radical, radical with a negative 1. Then we have minus 3 radical, 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 negative 1. So we're going to break down a 12 now into these 2 radicals. So you're thinking of your perfect squares like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, 25, 6 times 6, 36, so on and so forth. And you're finding one number from this list that goes into 12. I think I may have just given you the answer. 4 times 3 gives us 12. So now we're going to simplify even further. We know that we have 8 times square root 4 turns into a 2. But square root of negative 1, this is a fact that you have to memorize. Square root of negative 1 is the imaginary number I. So we attach an I, and then we carry down square root 3. Again, square root of negative 1 turns into I. So we have 8 times 2i, which is 16i, root 3. Now we're going to move over to the 75. So we have 75 being broken down into 3 radicals with the negative 1 on the very tail end. There's a number from our perfect squares list that goes into 75. See if you can find it. I found 25, and 25 times 3 gives me 75. So now we have minus 3. 25 turns into, or square root 25 turns into a 5. But remember, square root negative 1 now turns into an I, and we carry down radical 3. So now we have minus 15i radical 3. 16i take away 15i, with both of them having the same radical, means that we can combine the numbers in the front. 16i minus 15i is just I, or 1i, radical 3. If you want to try another example, here's number 5, very, very similar. If you try 5 on your own, ask for the answer key so that you can check your answer afterwards. Otherwise, flip with me to the next page. Number 6 says, write in simplest a plus bi form. So we don't want any squareds in our answer. We just want a plus bi, a real number plus an imaginary number. So we have a 4i outside of parentheses, and anything outside of parentheses, as you know, gets distributed. So we have 4i times 2, which is 8i. And then we have 4i times 3i, which is 12i squared, because I times I gives us I squared. Remember how on the front page, though, I said square root of -1 is I? Well, imagine me squaring this now on both sides. So now I have I squared is equal to, when I square a square root, they both cancel, which gives me -1. So I'm going to replace I squared with -1. So we have 8i plus 12 times -1. But 12 times -1 is now -12. And I'm just going to scoot this 8i over to the right-hand side so that it's in a plus bi form. Now you don't have to write that a plus bi, but you have to understand that the order does matter here. And you have to memorize that I squared is -1. We're going to simplify some more radicals. These are very, very basic in comparison to what we just did. So we're going to break down with the 6 in the front, radical, radical, radical. Find a perfect square that goes into 27, please. And remember that the last radical is a -1. Start simplifying, so we have 6 times 3, I square root 3. So we have 18i square root 3. Go ahead and try number 10 independently while I do it here on the video silently. If you need more time, just pause the video. I found 4i radical 3. In number 11 and 12, we have to write the following in simplest a plus bi form and then graph the result. So let's not worry about graphing right now. We'll get to it in a minute. But we do need to simplify. If there's a plus sign, we can simply just drop parentheses. 4 plus 9i plus 4 minus 6i. And then combine like terms. 4 plus 4 is 8. 9i minus 6i is positive 3i. When we graph, we have a brand new set of axes here. We still have x, but then the y-axis now turns into yi. So when we have this written as a plus bi form, this is really the same as x plus yi. So the x is represented by the 8, and the y is represented by the 3. So we go over 8 and up 3. And we plot the point. Typically, there's a vector drawn, just a little arrow pointing to the point. You don't have to put the arrow. The point is the main thing that you need here. Now number 12 is very similar, except that I see a minus sign in between here. And that's technically showing us that there's a -1 that needs to be distributed. So we have 4 plus 2i plus 1 plus 6i. From here we get to combine like terms. And now we go over 5, up 8, because again this is x and then y. Over 5, up 8. And you can draw the arrow there. Flip it once you got it. This next part's a little weird. We are converting I to some power as either one of these 4 options. 1, -1, I, or -I. And this actually goes with a cycle that we have, and we're going to try to sketch it at the top of our papers here. So to the right on a graph, we go over to +1. To the left on a graph, we go to -1. And if we think of our x, y, I axes, that means going upwards is +i, going downwards is -i. And there's a little trick here that we're going to use, and we're going to think of it in terms of, I guess, ice cream, scoops of ice cream. Every scoop of ice cream is 25 cents, but we start with 0 scoops of ice cream, so we have 0 cents. Then after 1 scoop of ice cream, it costs us 25 cents. After 2 scoops, 50 cents. After 3 scoops, 75 cents, so on and so forth. This little image will help you do any of these types of problems where you have to determine the value or express as one of those 4 options. So what we do is we take this exponent of 15, and in our calculators we divide by 4. 4 because there's 4 options. 15 divided by 4 gives us 3.75. Now, I don't care about this big 3 in front at all. What I care about is this 0.75. If I look at my little cycle that we just drew, the 0.75 lands me down here at negative I. So what we're saying is that I to the 15th is the same as negative I. So our final answer is negative I. Now we take a look at the next one. We have 36. 36 divided by 4 gives us 9. Now this is really 9.00. Same thing, right? So this 0.00 is what I care about. 0.00, if I look at my graph, brings me over here to positive 1. So again, what we're saying is that I to the 36 is equal to positive 1. I'm going to actually ask that you try 15 and 16 right now, just so you can get the practice. I'm going to do it independently and silently up here on the video while you try it on your own. Pause the video if you need more time, but I've got my answers and my work shown up here on the video if you need to check it. We're going to take a look down at here at number 20, and then we're going to move into something called the discriminant afterwards. So for number 20, it says to express in a plus bi form. So we're going to start by distributing, kind of like we did in that other problem, where we have negative 6i minus 10. I times I gives us I squared. Remember that we don't like I squareds because it says a plus bi form. It doesn't say a plus bi squared form. So we replace this with the value of, can you remember? Negative 1. So we have negative 6i minus 10 times negative 1. But negative times negative turns to positive. So we're going to move it to the front because it has no I anymore. And then we're going to move the negative 6i to the back. So we have 10 minus 6i. Number 23 is asking us to describe the roots of a quadratic equation where the discriminant is b squared minus 4ac. Hopefully you remember that from that crazy huge long quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. There you go, there's my Pop the Weasel song. So the discriminant actually helps us to determine the type of roots that we have, and we have 4 different options for types of roots. We have imaginary, which is when the value is less than 0. We have real, rational, and unequal. This must be greater than 0 because it's not imaginary, but it also must be a perfect square. We have real, rational, and equal. This is when our root or our discriminant comes out to be equal to 0. The only time you use the word equal is when it's equal to 0. And then the last one, real, irrational, and and unequal. This means it's greater than 0, but it's a non-perfect square. So I take a look and we see that it's already calculated for us. The b squared minus 4ac is 78. So if we think about describing 78, this is greater than 0. But if I take the square root of 78, is that a nice number? No way. This is a crazy nasty decimal, which means that it's irrational. because this is a non-perfect square. So we said it's real because it's greater than 0. We said it's irrational because it's a non-perfect square, and therefore the roots must be unequal. Choice D. Flip it once you got it. Taking a look at 26, we're going to stick with describing the nature of the roots a little bit longer. Here they give us the actual quadratic equation, and our goal is to first find b squared minus 4ac. And we do this by labeling our quadratic equation as ABC after the equation's equal to 0 and in standard form, where we have the x squared, the x, and then the no x term. So that's already happening in 26, which means that we get to just start labeling as A, B, and C. Because it's in standard form, that means that we get to just label straight across A, B, C. A is always with the x squared term, B is always with the linear term, and C is the constant. So go ahead and start calculating b squared minus 4ac. So we have negative 9 squared minus 4 times 5 times 1. Plug that right into your calculator. Don't forget the parentheses, otherwise you're going to be wrong. So we end up with 61. And because it's 61, this means that we have a number that's greater than 0, and it's non-perfect. That doesn't describe the roots, though. This is where we start describing with real or imaginary. Because it's greater than 0, it must be real. Because it's a non-perfect square, it must be irrational. And because it's real and irrational, that means the roots are unequal. This is the description that they're looking for. Go ahead and start number 27 by calculating b squared minus 4ac. So I end up with negative 39. And this is a number that's less than 0, which means that we can immediately describe the roots as imaginary. If you want more practice with this, go ahead and try any of these problems on this page. We have 24, 25, and 28. Again, if you try them independently, then you can ask for the answer key afterwards to check your answers. Go ahead and flip it once you got it. We've got one more topic to talk about. Our last topic is solving for the roots in a quadratic and expressing our answer in simplest a plus bi form. Lucky for you, we just did some stuff with the quadratic formula, b squared minus 4ac, but also last unit, unit 5, talks about using the quadratic formula quite frequently. So if you need to check it out, go back to unit 5, and it's in the first probably 10 minutes of the video. So when we're using quadratic formula, remember that it needs to be in standard form and equal to 0. So we have ax squared plus bx plus c equals 0. That's already happening in this first equation, so we can identify a, b, and c. Just go straight down the line as long as you have it in standard form. Then remember that we like to calculate b squared minus 4ac first. We like to calculate the discriminant. Four squared minus 4 times 3 times 2. When we type it in, it gives us negative 8. So now we have x equals negative b, which is 4, plus or minus square root negative 8, all over 2 times our a value, which is 3. We do need to write this in simplest a plus bi form. Notice the bi means that there's going to be an I in our answer. Hopefully you recognize that, though, because we have a negative under the square root. So we have negative 4 plus or minus radical, radical, radical. Negative 1's in the last one. All over 6. So take a second to think about how to break down square root of -8. So I found 4 and 2, so we have -4 plus or minus. Square root 4 and square root -1 both change. Square root 4 becomes a 2, square root -1 becomes an I. And then carry square root 2 all over 6. But remember, we like to reduce as much as possible because they tell us to. So we divide by a common factor, and in this case, it's a 2. So we have -4 divided by 2, which gives us -2. Plus or minus 2i divided by 2, which gives me 1i. Carry square root 2 all over 6 divided by 2, which is 3. Here's your final answer, nice and beautiful. Go ahead and move on to the next problem. We have 32, which is 9x squared plus 3x equals -1. Now that -1 sitting over there on the right-hand side is not so cool. Bring it to the other side, make it feel welcome. We have 9x squared plus 3x plus 1 equals 0. Start by calculating your b squared minus 4ac. And then plug in. I'm going to do this one silently while you work through this independently. You can pause the video, rewind it, do what you need to do to help yourself be successful. If you need more time, just pause the video. I found my final answer to be x equals -1 plus or minus 1i radical 3 all over 6. If you feel as though you need more practice with this, there are 2 problems on the next page to help you out with that. Remember that you can always ask for the answer key, or you can rewind, pause, go back, do whatever you need to do in order to feel prepared and ready to take your assessment.